Hello everybody, hope you're all well. Welcome back to the channel. I'm not really sure I should upload this video, to be honest. Well, I thought I would. It's a Sinclair QL power supply, which, as you can see, has been built from basically things I found lying around. So take this as tongue-in-cheek, or take it in the spirit it's intended. I'm not saying this is a solution that you should be following. There are other solutions that you can do, but I just done it for a bit of a laugh, to be honest. So just a quick flash inside there. We'll go over that. What I'm going to do, I'm going to go over the sort of the theory of it. I've got a schematic that I've found online. That's what it's based on, which isn't that one. It's this one on the QL forums 1024 Mac. That's the basis of it. So I'll walk through that and how how the QL gets the power it needs from that, and then we'll plug it in and we'll test it, the voltages, plug it into the QL and decide whether it's any good or not. Okay, and I've got to say, because this is mains voltages, you know, I'm not an electrical engineer, as you can probably tell by looking inside there. I'm not a power supply guy. This is mains power, so it's dangerous to mess around with. Don't do it if you don't follow my example. This is for information and entertainment purposes only. Okay, so don't follow what I've done here. So the original power supply, or the QL power supply, it output 9 volts DC at 1.8 amps, and opinions vary, but somewhere between 15 volts AC to 16.5 volts AC at 200 milliamps. It then takes that those outputs and it uses them in the computer. What the computer actually needs is it takes the 9 volts DC and it applies them to the micro drive motors. Then it spurs that off, drops it with a linear regulator 7805, which gives you your 5 volts for the logic. That's the CPU and what have you. Then it takes this 15 volts AC it takes this half of the wave, half wave rectifies it for a single diode, stores it in a cap, and then drops it with a 7L812, which is a 12 volt positive linear regulator. It's like a 7812, but it's a slightly smaller package. That has a total maximum input of 35 volts, and it will drop it down to 12 volts plus 12 volts. So this peak voltage is probably somewhere in the order of 20 odd volts, and it's dropping it down when it's stacked and held in this cap. It's dropping it down to 12 volts. Similarly, it takes the other side of that, the minus 12 volts, it puts it through a diode, stores it in a cap, and then it puts it through a 7912 or a 7L912 to get negative 12 volts. So in that way you've got 9, 5 plus 12 minus 12. So this is the design we're going to use to get the 9 volts, the AC and the 0 volts into this Sinclair QL. This is not my idea. This is designed by 1024 Mac, M.Kinsey, QL forums 2015, so quite a while ago. Quick aside, this whole thing is predicated on a 230 volt AC input, and it's a 15-0-15 transformer, so it's taking 230 volts and put out 15 volts. Not all mains voltage can vary. My mains voltage here is 240 odd volts, so when I'm looking at 15 volts on this drawing, what I'm actually seeing in real life is more like 17.5, and that has implications I'll come on to in a sec. So if I slip up and say 15, I actually mean 17.5, okay, because I'm reading the drawing. So we want to get 9 volts DC, 0 volts, and 17 volts AC. into the QL, which can then be used inside the QL, converted down to get 12 volts, 5 volts, whatever it needs. So let's start at the plug. We've got a 3 amp fuse, we've got a switch. I've got to just use a bit of lighting flex, you'll see in a minute. And then I've added a few things. I've put a XT capacitor, that's just to dump transients to neutral from the line, high frequency spikes. And I've put a MOV, a metal oxide varistor. And the idea is that if the line voltage goes crazy over voltage, you know, double or whatever, it will just short and dump it all to neutral. So that's just a little tweak. We've got a fuse I'll come onto here, and then we've got the transformer. Now this is a 15015 transformer, a 2 amp, 30 volt amp transformer. What that means is I can get 30 volts across both of these, but because it's got a center tap, I can get 15 and 15, but if it didn't have a center, if it was 2/3 across, it'd be a third and 2/3. It just means I can get half of it and half of it. So we're using the middle, we're using the 0 volts is the center tap. And that has implications for how we rectify the DC. We'll come on to in a second. So the 0 volts is nothing to do with earth, completely separate. Earth here is shown connected to earth and the plug. Maybe the chassis of the transformer should be grounded. I haven't done that. Maybe I should have done that. I'll show you that when we actually open it up. But 0 volts here and earth, totally separate things. So let's do the easy stuff first. We've got 0, great. We've got 15 volts, well, I said it again, 15 volts AC, 17 volts AC. So we're just going to tap off, before any of this happens, we're going to tap off one of these halves. There's our 17 volts AC, straight to the QL. Lovely. Inside the QL, that gets converted down to plus and minus 12 volts. We'll do that in a sec. We're running it through a 1/2 amp fuse just because the line wanted a 200 milliamp supply, so that seems sensible. Right, now we need the 9 volts DC. So we've got to rectify it, but like I say, because we're using we've got a common ground between the AC and the DC outputs here, we can't just use a normal full bridge rectifier. We have to use this thing, which apparently is called a split type. It's a full wave rectifier. How it works is this: you've got 240 volts flipping on the mains. It's flipping polarity. So is this by induction, flipping polarity, but it's tied in the middle to ground. So that means that this can be positive 15 volts or 17 volts. This will be negative 17 volts. Then it will flip, so this will be positive 17 volts, this will be negative 17 volts. So this thing's flipping polarity, tied in the middle to ground. So when this half is positive 17 volts, I'm going to put 17 there, because that's what it actually is. It goes through this diode, it lets it through. This is a 2 amp diode spec. I've used a 5 amp diode because that's all I had. But when this is 17 volts, it will let it through the diode, go through the fuse, charge up the capacitor. Nothing will happen here because this is negative, it can't go through the diode, only this side can. Then it will flip, nothing will go through this side, but it will go through this side, 17 volts, through the thing, charge up the capacitor. So this is flipping, charging up the capacitor through one or the other of these diodes. This is a 4700 microfarad cap, it's rated at 35 volts. The reason it's rated at 35 volts is because we're storing the peak voltage. We're not storing 17 volts, because when we rectify the voltage, the 17 volts is an average, root mean squared, it's here. The peak voltage is 1.41 times that. It's the peak voltage, there's a difference. So we're storing 1.41 times 17, which it turns out is about 24 3/4 volts, which happens to be very near 25 volts, which are some of the caps inside the QL, which we'll come on to in a sec. So that's how we're getting our rectified DC, and at this stage it's at 24 volts, 24 3/4 volts, sitting in a cap. So basically we're going to bleed off that cap to power this MP1584 regulator to get a 9 volts DC output. That's just a cheap step DC converter. Goes out for a 2 amp fuse, reason being 9 volts at 2 amps, or 1.8 amps, so that's that. Goes out to the QL. So that's a really rough and ready description of the power supply. I'll just quickly cover the fuse value. So we've got 2 amps because of the 2 amp output on the 9 volts. We've got 1 amp here because it's not 9 volts, it's want to double that a little bit more, it's 24 volts, so I put 1 amp there. And here we just have to take in the efficiency, the transformer. We know watts equals volts times amps, so we've got 9 volts at 1.8 amps, that's 16, plus 16 volts at a quarter of an amp. Basically, the QL needs 20 watts at maximum power. If it's 80% efficient, and to get 20 out, we've got to put 25 in. But we're putting 25 in at 240 volts. I know it can be 230, I know it can be 245, but we're putting in that at 240 volts. Watts equals volts times amps, so that means the amps is 0.1 amps. So the fuse needs to be 0.1 amps, really. But, you know, there could be fluctuations on the line, there could be inrush current, so allow another 25%. Even that only takes you to 130 milliamps or 0.13 amps. I've used the 0.315 amps because that's all I had. So we've got our outputs here, and what's actually happening inside the QL is got a 9 volts input here, which is already regulated by our buck converter. That's going in, driving the microdrive motors. And that gets put in a cap, so it's kind of conditioned again, and it's stored in that cap, and then it's bled off for this 7805, which outputs a very smooth 5 volts, and that goes to the 5 volt logic. So that's your 9 volts, your 5 volts. A bit more complicated, we've got our AC coming in, our 17 volts AC. 17 volts RMS, 24 3/4 volts peak AC. And all this circuit's doing is it's stripping off the positive half of that wave, rectifying it with a diode, sticking it in a cap, and then using it to power a 12 volt regulator. Taking the negative half of that wave, putting it through a diode, sticking it in a cap, and using it to power a negative regulator. But the issue here is these cap values here, 470 UF, 25 volts, 25 volts. We're storing 24.75 volts, and we're not sure what the line voltage is going to do. The line voltage could go up, could go down. So we're already on the margin. So really these need to be 35 volt caps, which I will do when I recap it. Incidentally, if you wanted to do the ATX mod, this is how you do it. And I'll link all this in the description. You rip out that regulator, and that regulator, and you eject 12 volts on its output, minus 12 volts on its output, and plus 5 volts on its output. You won't have motors and you won't have serial, but you'll be able to look at the screen and you'll have the logic working. Okay, so are you ready? Here we go into the depths of the power supply wire. Right, so I've used kicking off, I've used a bit of lighting flex, 2-core flex, with a rocker switch on it on one end, 3 amp fuse. And on the other end, we're using some 3 amp servo cable and a 3D printed plug. That 3D printed plug has been printed to the shape of the input of the QL, and we're also using one of these. This is a servo cable, which, as luck would have it, fits exactly, show you here, into the QL's power connector. You just have to swap the wires around if you want to colour code it. Let's have a look inside. This is a waterproof junction box from Electrical Wholesaler. You can see no expense spared here. I've drilled some holes in it for ventilation. I've heat tested this and it actually doesn't get above 35 degrees Celsius. Right, it's not plugged in, I've made sure of that. Output, input. So I've got 2-core flex. I haven't earthed the frame of the transformer. That's maybe something I should do. I'm not selling this. This is only for information purposes only. If I haven't said it enough, I'm not advocating anyone do this. I'm not advocating it's safe. It's some design I found off the internet. I'm doing it only for entertainment purposes and out of curiosity to see if it works. So this is the live, or the line. This is the 315 milliamp fuse I was talking about. That goes straight up, cable tied onto one side of the primary. This is the neutral, straight onto the other side of the primary. So on this particular transformer, the primary is on the top, the secondary is on the bottom. This is an old school iron transformer, complete galvanic isolation. This is a X2 safety capacitor just across the line in the neutral. The idea is any high frequency spikes on the line will get dumped from the line to the neutral. And just underneath it you might be able to make out, breached as well, that's a metal oxide varistor. It's a 470 volt metal oxide varistor. The transformer itself is bolted to a bit of FR4, that's just fiberglass board or PCB board. It's got no copper on it, it's just the board. That's bolted through there, and then the board itself is screwed in 4 places into the actual, you know, there's no way that's going anywhere, into the actual box. So that's the primary side. I don't know if there's a thermal fuse in here. It's a decent make though. I'll link this in the description. It's a 2 amp transformer, and the reason being, as I pointed out earlier, one of the rails, the 9 volt rails, has to be 2 amps. So I might be overdoing it there. It might be super mega cautious. You can get 1 amp versions, but I've gone with a 2 amp version. It's a big lump. So that's the primary side. This scoots you into the output stage, and here's the black wire. That's the center tap. It goes straight through and out to the plug. That's the ground. And then we've got the two 15 volt AC lines, which are actually close to 17.5 in this case. So we've got a bleed off of one of them through this fuse and out. So this is a 1/2 amp fuse for a 200 millivolt line, milliamp line rather, out along the white wire straight into the machine. So these are the 2 rectifier diodes. So the red wire goes into the anode of that diode. The white wire goes into the anode of that diode. Cathodes are tied together. So that is basically letting the positive half of the white wire through, the positive half of the red wire through. Rectifying the voltage, so stacking the peaks, so it's not 17.5 volts anymore, it's more like 20 odd. Put a coil on there, I can't remember why. I think it must have been to do when I was scoping the output on this thing. It helped a little bit with the noise. Go for a 1 amp fuse, go into this 4700 microfarad 35 volt cap. 35 volt cap because we're 20 odd volts of DC, so we've got a little bit of margin. And then that feeds this this MP1584 regulator that's tuned to 9 volts with the little pot there. And then again, this is me scoping on the output. I need to sort this out, make it a better, more permanent job of it, because I was just testing out different capacitor values, trying to squish any noise on the output. Out through a 2 amp fuse and then out to the machine. Okay, feeling brave, ready to scope some voltages. Rubber boots on, power on. So first of all I'm going to check the mains. 246 volts. So we're going to be seeing more than we're going to be seeing much more than 15 on the output, 17.6 on both of those AC rails. Attach the scope to the AC output of one of them. The peak voltage 25.2. Let's try the DC. I've got so much ripple on there. So that's with no load on it. Now I'm wondering whether, it's not terrible, but I'm wondering whether that's to do with the fact that the ground is common between the AC and the DC. What I'm going to do, turn it off, and I'm going to put a dummy load on it. Dummy load, 9 volts at 1/2 amp. Okay, so I'm going to turn it on. And I'm going to turn on the load. It's beeping because I've set it at 9 volts and it can't quite get there. By the time it comes down this cable, it's a little bit shy of 9 volts, that's why it's beeping. So let's just see on the output of the fuse, 8.94 volts. Once again, 8.94 volts, and now it's not doing that floating around thing. So I'm pretty sure that was just kind of ghost voltage, if you like, or the fact that it wasn't under load. I'm going to put the load up to 1 amp at 9 volts. 8.81 is what the dummy load's saying. At 1 amp. 8.98. 8.98 at the output here. Turn the amps up to 1.5. Sorry for the noise. 8.97. Won't go to 2 amps because it'll blow the fuse. I'll go to 1.75 amps. .97. So that's at the output anyway. What is at the other end of the wire, don't know, but at the output it's not sagging. You see now, so that's at 0.5 amp on the 9 volt rail. Voltage peak to peak 132 millivolts, so all the way down here to all the way up here. And now we're going to 1 amp. It'll probably get worse. Not that much worse. 180 volts, millivolts, 180 volts would be a problem. 180 millivolts of noise between the top and the bottom. So it's about 9.12 volts max. So just an experiment. I've snipped the leg off the cap, my dodgy output cap collection there. Turn it on. And that's the idle switching, that's with no load. So that's immediately worse. Got a 1 amp load on. $124 on the up. So it's helping a little bit, our cap. I'll just touch it back. That's with the cap. 100 without the cap. It's not making much difference, is it? With the cap. Without the cap. But I'm comfortable enough that this is okay enough to plug into the QL. Okay, we're back at the long-suffering QL. I've put the probe on the positive of that cap. That's this cap here, the one we were worried about. That's the regulator, plus 12 volts. And I've just picked up the ground there. Hopefully that won't come pinging off. It actually might be a better idea to put it a bit more solidly on there. Okay, got my safety goggles on, so don't want this cap blowing up. I have had that before when I put one on backwards. I won't be peering over it. So we've got 23 volts at the top, 20 volts at the bottom. So that's the ripple, if you like, on that cap. That's the charging, discharging, charging, discharging of the cap. So it will take it 23 point, call it 23.5, but the max rating is 25, and that cap's old and it's been sitting behind that heat sink. So it probably would be an idea to upgrade those caps. So that's fine, and we'll scope it quick. So that's the noise on the 5 volt line with this power supply, the Hombrew power supply. I'm just going to compare it to the V-Retro Design power supply. This is the V-Retro Design power supply. It takes a 12 volt input and it produces AC and DC off of that. So on the 5 volts we got about 350 noise on the 5 volt rail peak to peak. 9 volt DC from the V-Retro, about 460 millivolts. I was going to do a quick look at the output, the AC output on this Switchman power supply. with this little scope, because I don't know its main earth reference. I didn't want to risk the other scope, but I guess we won't be doing that because this has just died. I think I've used it 3 times in total. It won't charge. It was put away with a charge in it, and now it's kaput. So I don't know what happened there. I've only used this thing 3 times. I put it away and it seems to shit itself. I don't know why I'm laughing. It cost me about 50 quid, but I guess this is going to be our next repair video. I'll measure the output with a multimeter and we'll see if there's any specs on it to compare. So here we are, Hombrew power supply, Sinclair QL, and I've got TV just there. So let's bring the TV online. I'll be shot there in a minute. I might cover this in another video. I was going to try and do it in this one, but this is an OQTA drive, an open source microdrive thing based on a Raspberry Pi. And what I've managed to do is get some of the files from that onto a real microdrive. So don't get too excited. We've got Darts, Multi-Maze, Britain and Bomber, and they are shit. So what we're going to do is we're going to see if our power supply will let us do that. So let's flip the switch, which is more than you got on the original Sinclair QL. Hopefully that'll do. I've got the keyboard back connected up. So there's a microdrive. Microdrives away. dir mdv1 underscore. Might take a while. I'm not going to run it for hours with this supply because I haven't changed those caps yet. Load mdv1 underscore darts. Don't worry, it does that. So run. Darts. Press the key. And this sucks quite badly, so I'll just let it load this little bit, but the idea is you can see that it's running the microdrive, it's running the logic, everything is fine. It also runs the OQTA drive, no problem at all. Doesn't get hot, doesn't get warm. Only issue with it so far is it's over stressing those caps, or it's stressing those caps. I can't remember how to play this now. I think it's Control and Alt. There we go. Just for completeness, this is the V-Retro AC output. If I can get it to click. 16.94. So we're not a million miles away. Mine was 17.6. Unloaded, both of them unloaded. Let's have a look at the 9 volts while we're here. 8.93. Well, that's about going to do it for this one. Hombrew Sinclair QL power supply. Would I use it? Yes, I would. Does it work? Yes, it does. I think it works great. It was fun to build it, and I learned a bit about power supplies. And that was really the spirit of the video, was look, I found this thing on the internet, I'm no expert, let's build it and let's see if it works. So hopefully you enjoyed that video. Join me in the next video where we're looking at, this is an interesting one, it's a £50 AliExpress oscilloscope that someone sent in. Apparently it doesn't turn on or take a charge, and it failed after 3 uses, so hopefully that'll be an interesting one. Take care guys, I'll see you all soon.